Analyses of these spherules produced the same results found earlier in analyzing the natural material. This agreement substantiated the theory of cosmic origin of the collected spherules. The study of the Tunguska Fall is a part of the broader problem of the interaction of cosmic matter with our planet. This area of study in the USSR is directed by Vinogradov, a member of the Soviet Academy of Sciences. The work related to the fall of the Tunguska meteorite is complex and has been conducted in numerous scientific institutions. Kulik's map, based on aerial photographs, was refined. This map served as a basis for an experiment which simulated the destruction of the forest. The forest was represented by wooden sticks supported by soft wire. An explosive charge was set off above the simulated forest. The charge represented disruption of the meteorite, and the resulting air blast reproduced the pattern of destruction observed in the field. The destruction of the forest caused by the ballistic wave follows this pattern. The center of the impact area, without uprooting of trees and destruction of the forest, is duplicated just as it was observed at Tunguska. On the basis of these objective experiments, the trajectory of the meteorite and its energy were calculated. The tree samples obtained from the Tunguska area were studied in the Botanical Garden of the Academy of Sciences. Experiments were performed which simulate due to flash heating. Comparisons of the scorched trees in the Botanical Garden with samples collected in the field showed significant similarities. Here are pictures depicting the night of June 30th in 1908 in England, Denmark, and Russia. The night was very bright. The boundaries of this occurrence were determined by the Committee on Meteorites of the Academy of Sciences of the USSR. The area spread over the northern hemisphere west of Tunguska. Bezenkov declared that the Tunguska meteorite was actually a comet and cited the following occurrences as proof of its cometary nature: the destruction of the forest, the unusually strong pressure wave, the absence of large masses of meteorite material, the presence of silicate and nickel-iron spherules, and finally, the nature of the orbit of the cosmic body. Without any doubt, this was a comet. The approach to the Earth of comets from the distant cosmos is well understood. Comets consist of gases and small particles moving under the influence of solar radiation. A number of instances of comets approaching the Earth have been recorded. The approach of the Tunguska comet was not observed because it approached the Earth from the direction of the sun during the daytime. The tail of the comet, composed of cosmic dust, was caught at a height of 600 to 800 kilometers above the Earth in the northern hemisphere, and there it created an unusually bright night. The head of the comet approached with cosmic speed and upon entering the Earth's atmosphere, disintegrated into small particles, forming a shock wave. At a height of 10 kilometers, the remaining mass exploded, completely disintegrated, and particles were carried by winds far to the northwest. This was the sequence of events that led to the Tunguska phenomenon, which occurred half a century ago. While meteorite craters are preserved on the surface of the Earth for tens of thousands of years, the traces of atmospheric explosions are covered quickly by vegetation. And if the Tunguska fall can be considered a meeting of a comet and the Earth, then we can assume that such occurrences have happened previously. Kulik's persistent search for the Tunguska meteorite resulted in a more profound discovery than was originally anticipated, and helped increase man's knowledge of the universe.